Alright, so when you're doing kinematics problems, you're going to be using these three equations.
They're in the top left corner of your equation sheet.
Alright, so the first equation on your equation sheet looks almost like this. Let's talk about what each variable represents. Alright, V stands for speed. So when you have a variable, let's say the letter V for speed, right? And you write some other symbol or letter in the bottom right corner, so for instance, X for horizontal. This letter or symbol that we put in the bottom right corner is called a subscript. And so we could say V sub X or Vx. The subscript in the bottom right corner tells you about the variable. When you're writing subscripts, make sure that we can tell that they're subscripts, because sometimes people will write Vx like this, and their subscripts look very similar in size to their variables, and when you're in a rush, this is often exaggerated, and then you can't tell that this is a V sub x, it looks like V times x. So make sure that your subscripts are a lot smaller than the actual variable. This next variable here is pronounced V naught. The little circle at the bottom corner is pronounced naught. You may not have known that, but now you do. So the naught means initial
Or starting.
So whenever you see this little circle at the bottom right corner, that means initial. So we know the V stands for speed and the naught stands for initial, so V naught is initial speed or starting speed. A stands for acceleration. And finally, the T stands for time. I highly recommend that when you write T's, you write them with a hook. By drawing that hook, it'll be much easier to differentiate between your plus signs and your T's. Because when you're in a rush, sometimes plus signs will look identical to T's and you won't be able to tell them apart. So if you make that hook on your T's, then that ensures you won't make that mistake. Let's talk about the units of these things.
Or what these quantities are measured in.
When I put brackets around a letter, that means units. So the units of speed are meters per second. That's the same for starting speed or initial speed. It's still a speed, we're just talking about the speed at the beginning. The units for acceleration are meters per second squared. That squared is on the bottom, second squared. And time is measured in seconds. Not hours, not minutes, but seconds. Or just S. Now just give me a second here. Okay, so this is the equation written in its basic form, but actually it can be broken down into two equations. But don't get freaked out, it's not that bad. You see, when you're solving kinematics problems, all of these variables have to either be left or right stuff or up and down stuff. You can't mix horizontal stuff with vertical stuff in one equation. When you're using this equation, you have to use either all horizontal stuff or all vertical stuff, which is why we break this equation down into two separate equations, one for horizontal stuff and one for vertical stuff. When we're talking about horizontal stuff, we denote that with the letter X. So X represents side-to-side stuff or horizontal stuff. And so you can see the equation doesn't look all that different. All we did is we added a little x or a subscript x next to each variable to tell us that we're talking about horizontal stuff. So the variables don't change too much. So Vx means horizontal speed. Okay? So this x just means horizontal. So essentially, to all of these variables that we had up here, we're just going to add horizontal, except for time. So the units do not change because it is still a speed, it's just in the horizontal direction. You can break down what these variables mean by knowing what each subscript means. So for instance, when you see V naught x, that looks kind of scary, but you know that V means speed. If you know that naught means initial, and you know that x means horizontal, then you can piece it together and know that this is initial horizontal speed. V naught x is the starting horizontal speed or initial horizontal speed. Now, acceleration If we're talking about x stuff, we want acceleration in the x direction. That's a sub x is horizontal acceleration. The units are the same as regular acceleration because it's still an acceleration. All right, and finally, let's talk about time. So when we broke it down into horizontal stuff, we put an x subscript next to everything except time. Why didn't we do that? Well, you see, time doesn't have a direction.
Time is a scalar, as opposed to the other variables, which are vectors, and thus have direction.
There's no such thing as vertical time and horizontal time. It's just time. So the t is still time. The units are seconds. All right, and so we've broken it down into horizontal stuff. Let's talk about vertical stuff. So when we're talking about vertical stuff or up and down stuff, we represent that with the letter Y. So think vertical stuff. So again, our variables didn't change too much, but instead of an x subscript, we added a y subscript. V sub y is vertical velocity. Okay, the units are still meters per second. V not y. Remember, v is speed, not is initial, and y is vertical. So from all that, we get initial vertical speed. And the units are meters per second. A is acceleration. A y subscript means we are talking about vertical acceleration. The units are meters per second squared because it's still an acceleration. Doesn't matter which direction it is, the units don't change. And finally, the time. Again, the time does not have a subscript for it, x or y, because time doesn't have a direction.
It's a scalar.
You know the units for time are seconds. Okay, so I've broken the first equation down into about as much depth as you can get. Here's your initial equation. You break it down into two separate equations. The same equation for horizontal stuff and the same equation but for vertical stuff. And so the variables themselves don't change. You still have a velocity, a starting velocity, an acceleration, and a time. However, when you use this equation, you're going to be dealing with only horizontal stuff, and when you are dealing with this equation, you are going to be dealing with only vertical stuff. You cannot mix x's and y's in the same equation. Okay, on your equation sheet, the second equation looks like this top one. That is for horizontal stuff. As you can see, there are a bunch of x's. The same equation can be rewritten, replacing the x's with y's. And all that does is allow you to use the equation for vertical stuff. So I'm not going to redefine all the variables that you already know, but I am going to talk about the two new ones. So let's start with the horizontal stuff equation. This x represents horizontal position. Okay, not just any position, but horizontal position. So x is just where are you horizontally. X is measured in meters. Meters are just m. Moving on to the next variable, x naught, right? That's how we say that, x naught. Remember, naught means initial. So x naught is initial horizontal, because this is x, position. So where are you horizontally at the start? So again, if you know what x is, you can infer what x naught is, because naught means initial or starting, and so you just add that on, initial horizontal position. The units of x naught are meters again. So just a quick review, v naught x is initial horizontal speed, t is for time, a sub x is horizontal acceleration. All right, moving on to the vertical one, y. Y is also position, but vertical position. So where are you vertically? And because y is still a position, so it is still measured with the same units, and that is meters. Y naught is initial or starting vertical position.
It can also be called starting height.
So where are you vertically at the start? The units are meters. All right, and your third equation, this one is for horizontal stuff, as you can see all the x's, and this one will be for vertical stuff. Just replaced all the x's with y's.
The only thing I can mention about this equation is the x minus x naught that you see and the y minus y naught that you see. That's displacement because it's a change in position, the final position minus the starting position. So you can have horizontal displacement or a change in horizontal position, and you can have vertical displacement or a change in vertical position.
Notice the third equation does not have time. That'll be really important. Notice that all three of these equations have acceleration in them. What that means is you can solve for acceleration using any one of these equations. Here's a really helpful tip when using these equations. Well, when you're doing a problem, you label everything that you know and the one thing that you don't know, or your target. And then you look at these three equations and decide which one is going to work best for you. When using an equation, you want to have your target variable in it because that's the one you're trying to solve for. And then, hopefully, you know all the other variables in that equation, whether they're given to you in the problem or you solved for them earlier. Big hint number 1. Notice the third equation does not have time in it. There is no variable t. So, if you're not given time and you don't know anything about time, use the third equation. Okay, the other tip is if you need to solve for time, right? If you need to solve for time, then you can use one of the first two equations. Now, if the starting speed is 0, if v naught x is 0, then you can use either of the first two equations. Because in the second equation, if v naught is 0,
this term will go away,
and then it'll be easy to solve for time. Now, if the starting speed is not 0, then I highly recommend using the first equation if you can, because the second equation has a t squared in it, and that's going to make this more complicated to solve. So if the starting speed is 0, you can use either of the two equations, whichever works better for that problem, to solve for time. However, if the starting speed is some number other than 0, then I highly recommend using the first equation to solve for time. It'll be much easier than solving the second one. If you're going to use the first equation to solve for time, you need to know all three other variables so you can solve for time. So let's say you don't know the acceleration. Well, you can use one of the other equations to solve for acceleration. If you don't know time, you can't use the second one to solve for acceleration, but you can totally use the third equation to solve for acceleration,
because it doesn't have time in it.
Once you find the acceleration using the third equation, you can go back, plug it into the first one, and solve for time.
Okay, so here's kind of a general overview of when you want to use each equation. So you want to use the first equation when you don't care about the distance, the displacement, or how far something's gone. You want to use the second equation when it doesn't matter how fast something is going at the end, because there is no v final variable in this equation. And finally, the third equation I already mentioned, you want to use it when you don't know time.